Okay, Bismillahirrahmanirrahim. This is solution video for quiz 2 and quiz 3 with Madam Emilia section. Okay, session number 6. But if you are watching this and you're not coming from session 6, you're most welcome to try the question first before you look at the solution. Okay, question number 1. The question asks that you can please prove that the total power in the circuit given in figure 1 is equal to 0. So quickly you need to know that you need to show that the summation of power, you have to show that the summation of power equals to 0, or you can say that power supply equals to power absorbed. So you only have one supply, one voltage supply, okay? So you know that most likely this is where the power supply is, and everything else, as you know, resistor always absorb power. So you know that if you can either do like find independent current and then do I squared R, or you find independent voltage for the resistor and then you do V squared over R. So you can either use I squared R or V squared over R to calculate the power absorbed for each resistor. You can do that, or you can be like, okay, this is 8 marks only. Okay, there must be something here. So you know that you can like simplify the circuit, okay, to find the R equivalent. That is the 5 volt. You know that if you can find this IS, the power supply is 5 IS, the power supply. And then you know that this one here, the V is 5. The V is 5 volt because it is also in parallel. So you know that you can do V squared over R equivalent. You already have 5 squared over R equivalent. So this is another way you can do it. So those of you, I know that I can understand that when you said that some of you spend a little bit time on this question, all right? It meant to be that way, as in I do not want that it should not have only one way to do it. Okay, I'm taking any solutions you are going to give it to me. Okay, but then this is how best to do it. So quickly, you have to find your R equivalent. Okay, because you know that IS is VS over R equivalent. So R equivalent, when you look for R equivalent, go from the very furthest and then look. Okay, this is like in parallel. All three, they are in parallel. So 10 is in parallel with 35, in parallel with 15. Okay, once you do that, you notice it is in series with 30 and also 20. Okay, plug into your calculator. Okay, there's a function in the calculator which is the inverse. Okay, if let's say I just can draw it up here. There's at your calculator there is like this function here. Okay, I love to use that for if there's more than 2. I will use this function here on your calculator, and then I will do 1 over answer at the end. Alright, so quickly after you plug into your calculator, you will get this bit here is 5.12 plus 30 plus 20. Your R equivalent is 55.12. Don't forget your unit. Alright, then you have to find your IS. Therefore, your IS, that's not a 5. IS equals to VS over R equivalent equals to 5 over 55.12. Okay, you press your calculator, let the calculator do the hard work, and then you will get 0.091 ampere. Alright, now can you find the P power supply now? Yep, quickly you can just put the value in. 5 multiplied by 0.091, you will get around 0.4535 watt. Don't forget your unit is a watt. But therefore, how about this one here? The power absorbed. Okay, the power absorbed equals to 25. 5 squared is 25 over R equivalent. R equivalent is 55.12. Alright, and then you plug into your calculator, you will also get 0.4535 watt. Okay, if you just then later you show therefore P supply equals to power absorbed, I take it. Or you want to do like summation, you do negative 0.4535 is power supply is negative plus 0.4535 equals to 0 is also correct. Okay, with that, that is the solution for question 1A. Okay, so now the second part of question number 1. And so the question here 1B, it asks, consider the circuit in figure 2, and then the question says you have to calculate V1 and V2 by applying nodal analysis. Just so you know, like this is like a basic circuit, like the normal kind of easy, I have to put it that way, I have to say it that way. This is like the kind of easy kind of question in circuit. All right, so now those of you who hasn't attempted this question as mentioned, you may pause this video right now. In case, so those of you who just want have walked through the question, so here's how you do it. Now let me take the pen. Okay, so it's given to you V1 and V2. It's very straightforward, this question, and then you also have it already specified the ground, okay, the reference point. So quickly you can tell that, oh, this is a supernode. Okay, this is a supernode. Why? Okay, remember when there are when there is a voltage loss in between two non-reference essential node, this here is a supernode. Okay, so you have to do the boundary over there, and then you assume that you're not, you do not see the 4 volt. Okay, now let us do like current branching out at the supernode. So let's do this. So supernode. Okay, you have to forgive me for my handwriting. So all my students know that my handwriting is bad, so they have forgiven me long before. So now the first one I'm going to do here. Okay, so V1 minus, I'm seeing a dependent voltage source of 3I naught over the voltage, over the resistor of 1 ohm. And then I'm here now, current branching out, I'm at 2 ohm, is V1 over 2. And then straight away jump this side here, okay, for supernode, and then plus V2. Let me do this bit first since I've written the V2. So V2 is minus 0. You can actually write it if you want. So V2 minus 0 over 1 plus 4, they are connected in series. And then this current here is going into the essential nodes. As I'm doing current branching out, it's minus 2 equals to 0. All right, and then so what you do now, you know that, oh, there's another unknown variable of I naught. Where, what is I naught? I naught is the current here, the current passing through here. Okay, so what is I naught? I naught equals to V2 over 5. All right, so I substitute this into that bit there. Okay, so I will have V1 minus, because it's over 1, I can take away the 1, the denominator. I just substitute my I naught there, plus V1 over 2, plus V2 over 5 equals to 2. Alright, so now what do I do next? So I want to kill off the denominator. I'm going to multiply everything with a 5. That gives me a 5V1 minus 3V2 plus 2.5 V1, and then plus V2 equal to 0. Can I squeeze down here? I think I can. That gives me 7.5 V1, and that one is minus 2 V2. Oh, that's not a 2, that's not a 0, so forgive me, I'm sorry, that's supposed to be a 2. Okay, and then equals to 2. Okay. Oh, it's not 2. It's ayo. It's not 2. I'm sorry. I multiply everything with a 5. Forgive me. Forgive me. Okay, this is what happened when there's no retake for my video. Alright, so now there you have it. So this is your first equation. Brilliant. Now that is for your supernode. Okay, that's for your supernode. Yeah, I think I should put a note here so You might be saying that what am I doing here? I'll multiply everything with 5 to get this bit. Okay, now I've done with the supernode. Next, there must be one question by Kirchhoff's voltage law there. So I mentioned to my students, okay, the way best to do it, if you want to see it, you just put it back, and then you know that this is V1 and here is V2. Higher potential, higher potential, higher potential is a positive there, so it gives you V2 minus V1 equals to 4. Rearrange it back so that you can plug into your calculator. Oops, plus there equals to 4. All right, now you have your two equations. Now you might want to put into your calculator. Yeah, I think I should also do that. Okay. Alright, so after you plug into your calculator, you will get V1 equals to 3.27 volt and your V2 is 7.27 volt. So just like that, you get your 12 marks. Okay, as mentioned, this is an easier kind of question. So I hope you practice more when you are going to face your final. Alright, to the next question. So this is the second question, question number 2. This is 2A. Those of you who want to attempt again, this is where you stop. You pause. You pause the video, and then for the rest of you, we may proceed. All right. So, the question says by applying the mesh analysis method, you have to find the Norton current at the terminal AB. And then you have to find R Norton to complete the Norton's equivalent circuit. So quickly you know that what you need to achieve is you need to get like a current as well as the R Norton. You need to get your I Norton there, and you need to get your R Norton over there. Okay, so the idea is for you to complete the equivalent circuit, but it has a guided question. This one is a guided question, so it already instruct you to use mesh analysis. So you have to use mesh analysis. And for this question also, I have labeled to you the current, so hopefully that it will be much more easier for everyone to use. Okay, now when you look at the question and ask for Norton current, okay, the first thing you have to remember, I Norton is I short circuit. When there is no short circuit, if you remember, when there is no short circuit, you have to create one. If there is no short circuit, you need to create one. Oops, that's an ugly one. Let me just use this function here. So you need to create one. Oh, again, it's skewed. All right, now that's better. And the current is pointing downwards. Okay, so the first thing that you have to do when you want to solve for Norton's current, that's what you have to do. When there is no short circuit, you have to create one. Okay, that's number one. Okay, now, and then look into the circuit, and then you will notice that you have to use mesh analysis. You don't have to think of any other method. So now you start to do it. Now, when you look at the circuit, what do you notice? You notice that there is a current in between two meshes. So this is a super mesh. So this is a super mesh question. You are correct. So this is where the super mesh is. Okay. When it's a super mesh, you have to remember any resistor that is in series with the current source you may ignore. Quickly you remove 1 ohm. Now there's another trick to this question. Not so much a trick, it's to test your understanding. I always tell this to my students. We can create any kind of questions, but it really comes down to your understanding. So if you see here, there's 4 ohm over there, and once you created a short circuit, the electron is so clever. Okay, they would not want to waste energy to pass through resistor, so this 4 ohm can also be ignored. Okay, and just like that, now your super mesh question, super mesh equation. Okay, this is where you have to go basically. You can ignore the 4 ohm. So I'm gonna start with 3. Okay, let me do that. So 3 I2. Oh, let me do what's the bracket, Emilia? So let me put 3 I2 minus I1. I'm up here now, plus 2 I2. Straight away I go this way, right? And then I see the minus 20 I see the minus sign first. Up here, plus 5 I3 minus I1 equals to 0. Okay, then you just simplify it and you will get like, should I do it? Okay, I just make it as, let me just do it for you, and then 2i2 and then minus 20. I know those of you who can, like, you can straight away jump. I'm just going to put this down here for everyone to see better. So then I1, you see this one is I1, that one is, and that will be 8i1, 2 and 5, 2 and 5, 2 and 3, plus 5i2 over there, and plus 5i3. This 20, bring it over, equals to 20. This is your first equation. You have 3 unknown variables. You need to have at least 3 equations. Okay, just gonna keep it there. Okay, now when you have super mesh, there will be one equation by KCL. By KCL. All right, and then the way you do it is, I always tell you do that way, and then you see that the current 4 amp is going that way. Okay, you can draw any way you want, and then you can see that I3 is going up the same direction as 4 ampere, and I2 is opposing it. So you know your equation is I3 minus I2 equals to 4. This is your second equation. Okay, now the next one is here, the mesh one. All right, so mesh one there. So we start with minus 16 because I see negative first, plus, and then 3. Oh, I1 minus I2, that's a plus. Okay, let me just erase that bit. Let me erase so to make it nicer. Plus 3i1 minus I2 plus 5 I1 minus I3. So if you can hear my background sound, I apologize. Okay, this is the challenge that we have to face with working from home. Okay, that one is a 3. That one is 3, 5, 3, 8. Oh, that is correct. And that one is a 3i2, and that one is a 5i3 equals, I'm gonna 16 bring it over. That's a 16. Okay, got distracted a bit. All right, so now with 3 equations there, plug into your calculator. Okay, this time I have put the numbers into my calculator before I do this. It will be 22.5 over there, and don't forget your unit. Your I2 will be 18 ampere. Last but not least, I3 is 20. Oh, I said 20, but I put a 3. 22 ampere. Again, forgive my bad handwriting. Alright, so now the question asks for I Norton using mesh analysis. You're almost done. So IN therefore equals to what? You can see that here is also I3. IN equals to I3 equals to 20 ampere. So just like that, you get your I Norton. Alright, now let us do for R Norton. So if you remember, when you want to do R Norton, you must sketch a new circuit after turning off all independent sources. Okay, after turning all independent sources, let me just, I think I should do that so that you can see, so that you can actually see the question here. I'm just gonna put here on this side over here. Okay, oh no, I wanna put it here. Okay, I best to put it this way, right? So when you want to get for Rn, okay, you're going to put an ohmmeter at terminal AB. Okay, you have to turn off all independent sources. You have to sketch your new circuit. Okay, turn off voltage, replace it with short circuit. Turn off current. Okay, you replace it with open circuit. So that is what your circuit will look like. Yep. Oh, that's an open circuit over there. The rest are all the same. Short circuit, short circuit. Alright, so you would say that, oh, this is too ugly, madam, I still could not get it. Alright, so I'm just going to make it much more prettier then, so that you can actually see. You don't have to sketch the next circuit, but I'm just going to show you so that you actually can see that this is a very, very simple circuit. Okay, what I do is I just move this A to the top bit, and then the rest. Let me just put the value. I remove this 1 ohm, because it's no longer counted. It's an open circuit over there. That's a 2, that's a 3, and that's a 5. Alright, so now what do you notice? What do you notice? You notice that there's a short circuit again, madam. You and your short circuit. That's correct. This is a short circuit. So just like that, you will say that this 3 and 5, this is supposed to be 5, Emilia. Okay, it's not 8, this is 5. 3 and 5 can be ignored because the resistor is short circuit. They are both short circuit. So just like that, your Rn, therefore Rn is just, when looking at this way, you look from this very end and you can see that it is just 2 in parallel with 4. So 2 times 4 divided by 2 plus 4 gives me 8 over 6, aka 4 over 3 ohm. Alright. And to complete the circuit, to complete the question, the question say you have to write the Norton equivalent, right? And then you just have to sketch the last bit of your circuit. Putting that one there is a 22 ampere with a 4 over 3 ohm resistor. You are done. Just like that, you are done with question 2A. Alright, we will proceed to the last but not least question. So now, last but not least, question 2B. Again, some reference point for you guys who wish to try. This is where you press the pause button. Alright, and to the rest, let us go. So, question 2B state that, assuming that terminal A, B of the resistor circuit, this is a resistor circuit given in figure 4, it is said that is connected to the terminal A, B of your Norton equivalent circuit. So, the one that you did previously in question 2A, it says that then show that you can solve I naught by using current divider. So it means that you have to use current divider basically to find this I naught. This I naught is the current passing through 10 ohm. Okay, just so that you know, in case if let's say you ask, if let's say we have a current here, let me just call that Ix. Is Ix equals to I naught? The answer is no. Okay, here is Ix, and here is also Ix. Okay, but when we reach here, this is no longer Ix. So I naught is not equal to Ix. So, going back to your equivalent circuit, that is your equivalent circuit. Let us sketch. I know I can do this. Okay, you can also do that if you want. So that is the 4 over 3 ohm. And don't forget your Norton current of 22 ampere. Okay, so this is how basically you connect your Norton equivalent circuit to your resistor circuit. Okay, so if you have that sketch, you'll definitely get a point over there. Okay, and then now you have to use current divider. So if you look at, if you have this kind of question, so you know that you need to you cannot say that, okay, if I get the voltage here, then I will get the voltage divided by 10 ohm for me to get I naught. Okay, that way you might get some marks but not the full marks. Okay, the full mark is when you actually show that you can use current divider to get I naught. Okay, so this is how you do it. So first, I would like to say that if let's say I can like group this resistor, they are all connected in parallel as you did in question 1A. So if you notice in question 1A, it's pretty much the same. Okay, I just removed the 5 volt. Okay, so you might notice it, you might have not, but it's actually the same. I just removed the 5 volt, making it a resistor network circuit. So if you remember your solution from the first bit, you will know that getting 10 ohm and in parallel with 35 ohm, in parallel with 15 ohm, you will get that one. I think it's 5.12. Wait, 5.12 ohm. Alright, and then so if I reduce the circuit, then now it's gonna look like this. So remember, when you want to use current divider, okay, you must only have two resistors connected in parallel. Am I right? So this one is a 30, this one is a 20 ohm, this is 5.12 ohm. Okay, so and then you notice that these whole three resistors here, they are connected in series. You can add it up. All right, giving you the 55.12. Again, it is similar to what you did in your question 1A. All right, okay. Now, sorry. Oops. Okay, so after that, now can you get this current here? So I would like, well, basically I just want to find Ix. So if I find Ix later, I can find my I naught. Okay, and then so now, okay, Mariam, I'm recording. All right, so now I need to find my Ix. Okay, let me just put that. Sorry for the intermission. All right, so I need to find my Ix. Okay, so how do I get my Ix? So remember, by using current divider, I'm just gonna make a line over there. Okay. So Ix equals to opposite resistor over total resistor. In this case, okay, this whole bit after you add up is 55.12 multiply by the source. The current is from the Norton current. Okay, multiply by 22. You plug into your calculator, you should roughly get like 0.5196. That's 5. Let me just make it 5.2 ampere. Okay, so once you get this 0.52, this is the current here. This is the current here, passing through 30 ohm, 20 ohm, and 5.12. Okay, it is this current here. Okay, so Ix equals to 0.52 ampere. All right, and then now what do you have to do? So I'm just going to take this bit of the 10 ohm. Okay, and then I'm going to have that 35, and last but not least, that is the 15. Okay, that's the 15 ohm. This is my 0.52 ampere. The question asks for I naught. My I naught is here. You can only use current divider when there's only two resistors connected in parallel. So now you have three. What do you have to do? You group this bit. They are both connected in parallel. In fact, all three connect in parallel, but we just want to reduce one more set. Okay, one resistor. So you just add that two. They are connected in parallel. So 35 in parallel with 15. So 35 times 15 over 50. What is it? 35 times 15 over 50 is 10.5. You know, seldom that I make question and it gives like very good numbers. I always like applaud myself if I get good round numbers like this. Seldom. Alright, no, so now, so therefore I not. So once you get that number, I know you cannot do this because I am like have less space now. So I'm just gonna remove that. I'm just gonna erase that 35. I'm replacing that with 10.5. Okay, I'm taking this bit here. Alright, so therefore what is I naught? I naught equals to opposite resistor over total resistor multiply by not 22, is 0.52. Okay, plug into your calculator quickly and you should be getting 0.266 ampere. So just like that, you completed your question 2b. Get 8 marks for that. Okay, you can see that you have to actually do 2 times voltage current divider in this question. Okay, so maybe you will say that, madam, can I do a different way? As mentioned, we need to show like you show this bit here. As long as you can show like when you get I naught, you're using current divider. Okay, how you get the value of current Ix is up to you. Maybe you said that you want to do source transformation, and then you get R equivalent, and then you said you find Is. This is Is. Yep, that way also can, but you need to show this bit here. Oh, sorry. You need to show the last bit for I naught. Okay, because the question says you need to use current divider to find I naught. So however you want to get this ix, okay, in the end, when you want to find I naught, you need to show current divider only for you to get full marks over there. All right, with that, I'm complete. All right, all the best to you. Rewatch the video in case you miss out some things, and I apologize for a lot of interference while recording this video. All right, take care, everyone.